Hello, my name is Nashwan Ashari. I'm a cloud engineer working for cloud-based solutions. And in this video, I'd like to showcase how you can use Coriolis, our in-house cloud migration and disaster recovery as a service solution, to migrate a virtual machine from Oracle VM Server to VMware vSphere. Now, to quickly set the stage for our two environments today, our source environment will be an Oracle VM server we have deployed ourselves. However, Coriolis is capable of exporting from the fully integrated Oracle PCA solution as well. The destination platform will be a VMware vSphere with an ESXi host, both of version 6.7. However, Coriolis is capable of supporting any VMware deployment greater or equal to 4.0. The Coriolis installation itself is deployed as an all-in-one appliance within VMware vSphere, having this particular IP address. And in this demo, I'll be showcasing how to use Coriolis through its dedicated web user interface. However, Coriolis also features an easy-to-consume HTTP-based REST API, which can also be used from the command line client or third-party applications which are integrated with Coriolis. Now, one of the first things one might want to do when logging into a fresh Coriolis deployment is creating so-called Coriolis Cloud endpoints. These are basically resources which house the credentials Coriolis will be needing in order to interact with the various source and destination platforms it will be performing transfer operations to or from. The process of creating an endpoint is quite simple. You basically need to select what type of platform you'd like to add an endpoint for, let's say, for example, VMware. And based on the platform you select, you'll need to add some basic credentials and other information to point Coriolis towards that specific platform. I have already pre-created an endpoint for both our Oracle VM and our vSphere. The Oracle VM endpoint simply features the IP or host name of the Oracle VM Manager endpoint and a username and a password for Coriolis to use for its various operations on it. In my particular example, I'll be using the admin account. However, any user with sufficient privileges, such as cloning disks and creating virtual machines on OVM, should be able to create a Coriolis endpoint and use it for a transfer, no problem. Once we have an endpoint created, we can at any time come and click on this validate button. This will basically have Coriolis try to log into the platform behind the scenes with the credentials we have provided it, just to ensure the credentials are correct, and this endpoint can now be used for transfers. Similar to the OVM endpoint, the vSphere endpoint requires the IP address or host name of the vCenter, alongside with a username and a password. We're going to validate this one as well before we begin the demo, just to be sure. All validation has passed successfully. So now we can go ahead and create transfer actions between these two platforms. Coriolis supports two types of transfers. One of them is the so-called normal migration. This is a one-off lift and shift operation which treats the VMs as a black box and simply moves them from the source platform to the destination platform and boots them up in one single operation. Alongside this, there is the Coriolis replica. This is more of a disaster recovery oriented operation. It basically decouples the disk syncing stage and the actual final instance deployment stage from a normal migration so that users can sync the storage of VMs from a source platform to a secondary backup platform. And should disaster strike on the source platform, they can go ahead and deploy virtual machines from the previously synced storage on the backup platform. For this demo, I'll be creating a replica. However, the parameters for both of a replica and a migration are virtually identical. The first stage would be to select our source Coriolis endpoint. In our case, it would be the Oracle VM endpoint I've shown here. Next, we need to give Coriolis some options related to the source environment. When exporting disks from Oracle VM, Coriolis will be using a temporary virtual machine, which will perform hashing of the disks of the VM and also performing the actual data export itself. In this sense, we need to tell Coriolis the name or ID of an existing template on Oracle VM, which it can use for this. This VM needs to have a preset username and password, and we need to tell Coriolis what those are for it to be able to log into the template once it boots it. We can also select the storage repository and server pool we would like this temporary VM to be created on. And we can also select the type of disk cloning Coriolis should use when cloning the disks of the source VM before exporting the clones. In most situations, the thin copy option is the best one, especially in terms of time and storage efficiency. However, our particular Oracle VM deployment does not support it, so I'll be going with the next best thing, which is the sparse copy option. Once we have set these source options, we can go ahead and select which instances we would like to move. The instance I'll be showcasing today is this one. It's a simple Oracle Linux 7 installation. It has 2 vCPUs and 2 gigs of RAM. There's nothing particularly special about it except that it has a relatively small root disk to facilitate the speed of the transfer in this case. And it has a single network interface with this particular MAC address, which is connected to the OVM network marked with this label. Just to quickly log into the virtual machine, there's not much going on here currently. I'm going to be creating a file. So let's say see you on VMware and redirecting that to a file called migration.txt. And I'm also gonna be adding a timestamp to this file before we do our actual demo. So we're gonna go ahead and search for the instance's name here, select it, and then go off to the next stages. Next, we need to select an endpoint for our target platform, in our case, the vSphere endpoint. And now we will need to select some options related to the transfer on the destination vSphere platform. First and foremost, we need to go ahead and select a data center. In my case, it would be data center 1. We can go ahead and select a cluster. Based on the data center and cluster selections, we can then go ahead and select things like the data store we'd like the VMX files of the VM to be stored on, a folder in which we'd like the virtual machines to be migrated into, whether or not we'd like Coriolis to enable CBT for the virtual machine once it migrates it, the hardware version to use for this virtual machine, the resource pool to use based on the selected import cluster, whether or not we'd like Coriolis to automatically power on the virtual machine after completing the transfer, the guest ID to use for this virtual machine, whether or not we'd like Coriolis to use VMXNet3 as the device model for the VM's network interfaces, or one of the other selections, whether or not we'd like Coriolis to preserve the MAC addresses on the network interfaces of the virtual machine on VMware, and whether or not we'd like Coriolis to automatically reconfigure the virtual machine to use DHCP on the destination platform, which we do not in this case. Additionally, the actual disk writes on VMware will again be performed through a temporary virtual machine, and we need to give some options related to that temporary machine. So we need to select a cluster for it. We need to select a data store we'd like that temporary virtual machine to be stored on. We need to select a folder in which we'd like the temporary virtual machine to reside in while it's running. We need to select a resource pool for it, provide a template for it. In this case, I have pre-prepared a Ubuntu 20.04 template, but any Linux template should do. The template needs to have a pre-created username and password, which we need to pass to Coriolis using these options. And additionally, we'll also need to tell Coriolis a template to use for shell operations, for disks, for disk operations such as creating disks, managing them, and resizing them. I will be going into more details about this once we see the actual transfer going. So once all of these options are selected, we can go ahead and click Next. In this stage, the so-called network mapping stage, for each network on OVM which this VM is connected to, we will need to provide an equivalent network on VMware. So Coriolis actually noticed that this VM has a single network interface, which is attached to the network bearing this label. So for this network, we need to provide an equivalent on VMware, which can either be a distributed virtual port group of a distributed switch, or we can also tell Coriolis to attach to a simple VM network. Once this is done, next comes the so-called storage mapping stage. Here we can decide which data stores each disk of the virtual machine should go to on VMware. If we'd like all of the disks of the VM to go to a specific data store, we can use this default storage option. If we'd like to map each specific storage repository on the source OVM, which this VM has this on to a specific data store, we can use these options over here. Or if we'd like more fine-grained control on where each disk ends up on VMware, we can go ahead and use the individual disk mapping options over here. These options operate in a hierarchy, so the latter ones override the former ones. In this case, because I provided a specific disk mapping at the bottom here, this VM's disks will go to data store 0. Next comes a stage where we can optionally add some scripts Coriolis should execute within the virtual machine before booting it on VMware. This allows for further customization of the operating system in case it's required before the final boot on the destination platform occurs. Optionally, we can add schedules for Coriolis to automatically perform syncs, considering we're using a Coriolis replica. This is this disaster recovery as a feature of Coriolis, and we can specify automatic sync schedules based on any metric we want. So let's say we want every Monday at 3 a.m. and keep adding as many schedules as we wish here. I won't be using any schedules for the purposes of this demo, but this option is here in case people want to have Coriolis sync virtual machines automatically. Finally, we're presented with all of the options we have selected so far. If for whatever reason some of the options seem incorrect, we can go back and edit them and make sure they're correct before clicking finish and having the replica created and synced for the first time. In the interest of time, however, I have already pre-created a replica of this virtual machine. The options I used when creating it are basically the exact same ones I have shown you previously. I have just executed this replica once before in order to save on the initial sync time. If at any point we'd like to have Coriolis perform a sync of this virtual machine, we can come over here and click on execute. Because we are using the sparse copy cloning method on OVM, this requires the VM to be shut off while the disk cloning is happening. However, if our OVM had supported the thin cloning disk cloning type, which is more optimal anyway, we would have been able to clone the disk of the virtual machine and transfer its data without turning it off on the source. In my case, I'm going to select shutdown instances and then click on execute. Now, all Coriolis transfer operations are split into a collection of smaller subtasks, each of which, if possible, are executed in parallel. Going from top to bottom, we have some tasks which perform validation on all of the inputs we have provided. For example, for OVM, Coriolis is double checking that we input the correct VM template, storage repository, and server pool name for the temporary VM. It'll then go ahead and fetch all of the information of the source VM from OVM, such as its compute footprint, like CPU and RAM usage, what disks it has attached and on which storage repositories, as well as what network interfaces it has and how they are configured. Once that is done, there is a stage where Coriolis will validate all of the inputs related to the destination VMware. So things like the cluster we selected, the resource pool, and it will also double check the template we gave Coriolis in order to perform disk syncing through. Once all of these operations are done, Coriolis will then go ahead and deploy or reconfigure the replica disks on VMware. Because this is a subsequent replica execution, Coriolis has already synced the disks of this VM once, so it's just telling us that it's going to reuse the previously synced disks. If we go back, however, to the first replica execution in the chain and look at the deploy replica disk tasks, we can see that Coriolis is creating the new disks through the use of a shell virtual machine. The use of a shell VM is required on VMware versions less than 6.5 because they do not offer the first-class disks functionality. In this sense, Coriolis will be cloning a template and performing all disk operations like disk creation and resizing and so on through the use of that template. As we can see here, after Coriolis cloned the template, it created a new empty disk on VMware with this particular data store path. If we switch over to VMware and go to the data store viewer, under that path, we should be able to see the disk file Coriolis has created. Initially, it was empty. After the first sync finished, it contained the state of the virtual machine during that initial first sync. Once disk creation is completed, Coriolis will then go ahead and deploy whatever resources it needs on both the source and destination platforms. As mentioned on OVM and on VMware as well, Coriolis will be booting a temporary VM to facilitate the disk export and import respectively. If we switch over to OVM, we can see this temporary VM over here, which was created from the template we had selected previously. As we'll see later, this VM will have a clone of the virtual disk of the VMware migrating attached to it, and it will be used to export the disk data. On the VMware side, again, Coriolis will be booting a temporary Linux virtual machine. If we switch over to VMware and go to the VM inventory viewer, we should see this virtual machine here. Additionally, if we double check its configuration, we should see that alongside the root disk this VM has from the template it was spawned from, there is also the secondary disk that Coriolis has been syncing to attached to it, and Coriolis will be syncing to this disk file through the use of this temporary VM. Next, Coriolis went ahead and shut off the VM on OVM. As mentioned, this is required because we're using the sparse copy disk clone type. If we were using the thin cloning clone type, this would have not been required and could have been skipped. And finally, Coriolis reached the replicated disk stage. In this stage, it will be cloning the disks of the VM on Oracle VM and attaching them to that temporary VM it created during the previous task in order to perform the actual data export. If we switch over to OVM, we should see that Coriolis is currently cloning the disk file of the virtual machine. And once the actual cloning process will finish, we should be able to see Coriolis attaching this disk to the source export worker. It's currently doing the attaching process, so if we switch over to OVM, we can see that indeed there is the clone of the disk of the source VM, size 6 gigabytes, attached within slot 3 of this temporary worker VM. After the disk's attachment, Coriolis will then perform the chunking operations on the disks. Here, Coriolis basically splits the disk in 10 megabyte chunks and hashes them in order to have a reference for future syncs. As we'll be seeing, because this is the second replica sync in the chain, Coriolis will only be transferring over the areas of the disk that have changed from the previous sync operation. If we look at the first replica sync I did, we can see that after chunking, Coriolis had to transfer over about 1.8 gigabytes of disk data. These were the areas which were actually allocated within the virtual disk. So despite the disk having an actual size of 6 gigabytes, Coriolis determined that only 1.8 gigs or so were actually allocated and needed to be transferred over. Going back to our current replica, we can see that after the disk chunking has finished, Coriolis has determined that the total this changed area size is about 300 megabytes, so about 30 10 megabyte chunks. and it will start transferring over these chunks using the source VM on OVM to export the chunks and using the destination VM on VMware to actually write them to the disk file on VMware. This process obviously is considerably quicker than transferring the whole disk from the start. The advantage of using Coriolis replicas is that you can do subsequent syncs at whatever frequency you like. So you could potentially see a very few disk change areas between syncs, and syncs themselves can last a very short amount of time. So now that the disk syncing has completed, Coriolis will then go ahead and clean up the clone disks on the source OVM, and then proceed to delete the temporary resources it had created both on OVM and on VMware. So if we switch back to OVM, we can see that the virtual machine which was doing the export has been deleted, and now Coriolis is also deleting the cloned disk. And on VMware, we should see that that temporary VM which did the disk writing has been deleted, and the disk file has been detached before its deletion and is available over here on the data store we had selected for it. As we speak, this disk now contains the state of the virtual machine which it had when we performed the sync just a minute ago. Now let's say disaster strikes on the source, or it's time to schedule the switchover between the source and destination platform. You can simply come over here and click on the Create Migration button for this replica. We can optionally select user scripts for the OS morphing process, which I'll be explaining shortly here. And we can also tell Coriolis whether or not we'd like to force the transfer, so ignore disk cloning errors, or whether we'd like Coriolis to skip the OS morphing process. I'll be explaining what the OS morphing process is shortly, but we do not want to skip it because the source and destination platform's hypervisor technologies are different. Sen on the source Oracle VM and ESXi on the destination VMware. So now we simply click migrate, and Coriolis will now create a migration operation from the disks of this replica. We can click on view migration status and it will take us to the migration operation. There is again an initial validation stage where all of the options are double checked by Coriolis. Afterwards, Coriolis will go ahead and deploy a temporary virtual machine to perform OS morphing. What the OS morphing process is Coriolis basically adapting the offline disk image of the source VM to the destination platform's underlying virtualization technology. Because we're moving from Xen to ESXi, there are some changes we'll need to do to ensure this virtual machine will boot properly on VMware. All of these changes will be highlighted when we reach this OS morphing task. This OS morphing process is again done through a temporary virtual machine which will be spawned on VMware, and it will have the disks of the virtual machine we just synced over attached to it. So if we switch over to VMware and go to the VM inventory viewer, we should see Coriolis is currently cloning that template into the OS morphing worker VM. Once this is done, Coriolis will then go ahead and attach the virtual disk we have synced to so far. If we click on Edit Settings, we should be able to see that the secondary disk of this virtual machine is that disk we've been syncing to this whole time. And after that is done, Coriolis will begin the actual OS morphing process once this temporary VM boots up and it obtains its IP address. Now, the important thing about the OS morphing process is that it is highly dependent on both the source and destination platforms we're transferring to and from, and also the operating system release of the virtual machine we're transferring. Coriolis supports OS morphing for all major Linux distributions. That includes Oracle Linux, Red Hat Enterprise Linux CentOS, Ubuntu, Debian, and a bunch of utility distributions such as OpenWRT for routing, CoreOS, and more. And on the Windows side of things, Coriolis supports OS morphing for any Windows version which is actively supported by Microsoft. This includes both the server versions of Windows and the client or desktop versions of Windows. In this case, because we're moving an Oracle Linux 7, Coriolis will take the appropriate steps it needs to take for Oracle Linux 7 releases. As we'll be seeing shortly, Coriolis will begin the OS identification process. It should be able to determine rather quickly that this virtual machine is an Oracle Linux 7, and based on that information, it will take the appropriate actions. These include removing any packages which the VM had on the source platform, which might not be necessary on the destination anymore. In our example here, this will be the OVM integration agent. And it will also install any packages which might be necessary for the VM on the new platform. In this case, the open source version of VMware tools, which provides various integration services for the virtual machines on VMware. After the package removing and addition stages, Coriolis will perform any other actions it deems necessary for this virtual machine to boot on the destination. In our case here, because we're moving an Oracle Linux, Coriolis will be rebuilding the init RDs for all of the kernels, which are pre-configured within this virtual machine, and it will be performing a bunch of other operations behind the scenes, which will facilitate the booting process on the new platform, such as, but not limited to, reconfiguring the networking if we had selected that option when creating the replica. It will go ahead and set SE Linux to perform automatic relabeling on first boot to make sure there's no SE Linux related issues, and some more things which will not be listed in these event messages since they are a bit less noteworthy. Coriolis has now gone over to rebuilding the initRD for the main kernel after it finished with the secondary one here. These operations are why we always recommend people use the OS morphing process when moving between two platforms. However, if I had been certain that my virtual machine would have booted properly on the destination VMware, I could have skipped this OS morphing process entirely. In which case, these three subtasks you see here, which are related to OS morphing, would have basically been skipped entirely, and Coriolis would have immediately gone to the final VM creation task over here. Okay, so the OS morphing process is now finished. After all the operations are done, Coriolis will dismount all of the partitions of the disks of the VM it's been OS morphing, and it will go ahead and remove the temporary resources off of VMware. So we can indeed see that that temporary virtual machine has disappeared. And afterwards, Coriolis will finalize the creation of the final VM on VMware. So if we go over here and check, we can see that within the folder we had selected for this machine to be created, we can see the virtual machine freshly created right here. If we check its settings, we should be able to see that its root disk is this file we've been syncing to and OS morphing this whole time. And additionally, its network adapter should have the same MAC address it did on the source network, which it does. And additionally, it's using VMXNet 3 as a device model because that is the option we had selected. Now let's see the final VM. The initial boot for Red Hat-based systems takes a bit longer since the SE Linux relabeling has to happen. However, once it performs the relabeling and the VM will reboot once, we should be able to log into the freshly migrated system. Okay, so there was the reboot. I can go ahead and select the default kernel. And now we can log into our migrated virtual machine. This virtual machine has all of the state it had before we did the previous replica sync. So here is that file with the timestamp we had created previously. It has its root disk with the same original size it had been using initially. It has the same amount of RAM it had on the source and the same number of vCPUs. And additionally, it has the network interface with the same MAC address it had on the source platform as well. As an added bonus, because Coriolis installed the VMware tools, we can also see that the IP address was automatically reported to VMware as well as the DNS name. And additionally, any guest integration features which are available for machines featuring VMware tools will be available for this virtual machine. So for all intents and purposes, this virtual machine feels as if it had been created on VMware to begin with. That concludes our demo. Thank you very much for watching. If you have any questions or need any information regarding Coriolis, please visit our website at cloudbase.it. There's a dedicated cloudbase.it/Coriolis page you can look up. And additionally, we have a contact form on our website for you to ask any questions you'd like to us directly. Thanks again for watching, and I hope to see you using Coriolis to migrate your workloads soon.